And we are expecting a Flux multi-tenancy presentation today. Just give it another couple of minutes for anyone else to join.
Hey everyone. I am Sanspar. I am a part of the Flux maintainer team. Paolo, who's another Flux maintainer, he's having some trouble joining the meeting. So just give him a few minutes to figure that out. The link is not working for him for some reason.
Sure thing. I will just paste another link back in here, which might be useful.
Sure, thanks.
Okay, in the meantime, let's get started. So welcome everybody once more to the EMEA time zone friendly ag security. Just a reminder that this meeting is being recorded and live streamed to YouTube. Your participation in these meetings is an agreement to abide by the Cloud Native Security Code of Conduct, which can be found in the repo. I would like a person to volunteer as scribe, if anybody's available, to ensure all actions and primary content is recorded in the written notes, be referred to later, both here and by our colleagues across the pond, around the world. And for existing members and working group representatives, please remember to include your organization or company along with the working group you're involved with, and any updates if you would like to share anything with everybody else. And I don't think we have any new faces this week. We are expecting a Flux presentation shortly, so maybe we could just have a scan through any open issues in the meantime.
I also want to just say hi. I don't think I'm trying to drop by the EMEA meeting a bit more often, but just wanted to introduce myself. I'm Brandon. I'm a fellow co-chair along with Andy and Aradna, and yeah, my DMs are open whenever people have questions or want to chat about anything.
Yeah, absolutely. And Brandon has been facilitating many of these meetings for a good while now. So yeah, very nice to have you with us, sir. And hello to hi to John. How do you do?
Hey, can you hear me all right?
Yes.
Can you hear me? Okay. I just had a brief update for the controls project. So we are, I think I mentioned this in the US meeting, but for this one, we're gaining a fair amount of traction, and the group size has expanded quite a bit. We're working on a roadmap. So Brandon, I think you had asked for us to present that that roadmap back to this group. Is there a preference on which, the US time or the EMEA time?
No, it's no preference, just whichever works for you and collaborators that you work with.
Sounds good. It'll probably be the US based time then for Pratik, because he's out west in the US. So anyways, we'll get that on the schedule here soon, but we have a draft up and it's undergoing peer review for the roadmap.
Awesome.
Cool. Thank you very much. And we do have a scan through the non-EMEA, I guess, notes in these meetings. So we will still try our best to sort of catch up on those as well, John. Thank you very much. Any other updates? Okay, so just in the interest of getting the presentation going, we'll just skip through the issues. Last week's meeting was Cubescape in the US time zone, single pane of glass for Kubernetes security, security posture, policies, and workload protection. The presentation slides are in last week's notes. A few updates. The supply chain questionnaire has gone out, I presume. It didn't actually make the meeting. I'm just reading back through the notes. Hexa, which presented, if I remember correctly, a graph-based authorization framework based on a Google paper here a couple of months ago, has been accepted into the sandbox. The serverless group is no longer active, but it's being rolled into V3 of the white paper. And the controls working group, feedback on version 1 is being addressed, and lots of collaboration opportunities. If people would like to jump in on the issue, that is in the backlog. Sanskar and Paolo, are you gentlemen in a position to jump into your presentation this week?
Yeah, sure.
Wonderful. Please, over to you in that case.
Brilliant. So let's start sharing my screen. Can you guys see my screen at all now?
Yep, that's good.
Brilliant. So yeah, I'm Paulo Gomez. I work for Waveworks and I'm a core maintainer on Flux. Sanskar, do you want to introduce yourself as well?
I already did, but let's do it again. Hi everyone, I'm Sanskar. I also work for Waveworks and I am a Flagger maintainer.
Brilliant. So let's crack on. So just to start, we are presenting this especially because we had a security audit last year and they recommended us to have some other like security views, especially on the multi-tenancy, which at the time we were working on, and also on some other parts that we haven't had much views from a security perspective, including Flagger. So we created those issues that you guys should be familiar with, which is the security pose submission. And then on the back of that, we created this issue on the presentation, just to kind of explain why we're doing this. The idea is for us to pretty much go through Flux, how it works, the basics, cover some of the multi-tenancy aspects, then talk about Flagger and the scope of the security powers. So first of all, Flux was the first tool to start implementing what is known as GitOps. GitOps is pretty much you having a declarative state for a Kubernetes cluster, and which is versioned and immutable. And then you have a tool, in this case, Flux, which would pull this state and continuously reconcile that against one or multiple clusters. So just to think about that in very simple terms, you would have an engineer or DevOps SRE engineer committing something against a Git repository, and then you would have Flux inside of a cluster pulling that state and then continuously trying to reconcile that against the cluster that it lives in. I put a link there for the Flux end-to-end, which kind of details a bit more, different perspectives and goes into more detail on all that flow, and kind of, let me quickly open that, goes through like different workflow diagrams and so on, just to make it really crystal clear everything that happens behind the scenes. But going back to this and expanding a bit the example, Flux can also observe different sources. So for example, instead of just a Git repository, you can have your state into a bucket on a cloud provider, or you could also have that on a OCI repository, which makes it really flexible for you to store and pull that that source. It doesn't necessarily need to be pull based. Flux also supports a reactive approach. So instead of constantly pulling to check for changes, what you can have is a event happening. So for example, you had a pull request merged that could trigger an event from GitHub, for example, which one of Flux components would receive and then go and say, look, source controller, you need to pull the latest from this repository. And conversely, we don't support only in-cluster reconciliations. We also support what we call remote apply. So for example, you can have Flux running in one cluster and applying reconciliations across multiple clusters. And these will kind of make a bit more sense, especially when we talk about multi-tenancy. Brilliant. So this is overall what Flux does. When we start going through its components, again, like Flux has a bit of microservice architecture. So you have components that are responsible for specific areas. So you have source controller, which pretty much fetches sources from the different types that I mentioned already, and then you store them as artifacts that other controllers can then pull. And then you have customized controller and Helm controller, which would get this artifact and apply that either against the cluster directly, in the case of customize, or Helm controller, which would then talk with Helm to apply Helm releases. And all that, again, happens behind the scenes. Another core component is the notification controller, which works two ways. So it works on receiving notifications that sources have changed. As I mentioned, for example, you have a pull request that was merged, and then you can get a webhook from with GitHub, which will then notify the notification controller, and notification controller will then talk to source controller to pull those sources. Or you have the notification outwards, which would, for example, send a message to your Microsoft Teams or Slack or Rocket Chat, which will tell this reconciliation was successful, or it failed, or even this is now successful after X amount of failures. So these kind of are the four core components. So again, source controller fetches the sources, Helm and customized controller apply those, apply the state against the cluster remotely or in cluster, and notification, which receives and sends notifications outwards. On top of those core components, we have some additional components that makes it quite interesting when you managing images. Well, when you have applications that depend on images that you don't control, for example. So imagine you have deployed a given application, and what you can do with the image controllers is you can constantly monitor a container image repository. So let's say you have Cert Manager in your cluster. So you can go there and say, look, I want to check if there are any updates within this semver. And as soon as there is one, I want you to apply this policy. So what would happen is, behind the scenes, as soon as that application releases a new tag on their Docker Hub, for example, the image reflector would fetch the latest tags, would tell image automation, which would then change your declarative state, so your YAML file that has the image name and tag, and we'll commit that into your Git repository, and then the whole loop starts again. You have the source controller pulling up the latest, and then you have either the Helm controller or customize applying that change to the cluster, which means you're getting the latest version of the application without doing anything. Cool. So again, all components we have are the core components that I mentioned before, and then the 2 additional image-related controllers. Now, when we start talking about multi-tenancy is, which is the core of the presentation, I just wanted to first kind of talk about how we covering multi-tenancy terms. So in some of our RFCs, we're just talking about soft and hard multi-tenancy, which is also the terms used within the multi-tenancy working group upstream. But the key thing here is we have a shared cluster, which is to be used in high trust environments. There are so many different problems that could happen within that goes beyond Flux control. Some of them are inherent of Kubernetes, some of them are inherent of sharing hardware or network and so on. It's a low isolation level deployment. So, we could and we can to some extent enforce some control plane restrictions, for example, RBAC, but there are other low level isolation, for example, a host, the host shared across workloads, for example, that goes beyond Flux kind of capabilities really, because that is a tenant to or cluster domain to on. On the other side of the spectrum, you have a hard tenancy, which is more about tenant dedicated clusters, which means you can have untrusted tenants and you have a better safety net in terms of them being able to jump across other tenants' resources or being a noise neighbor and EOSing other tenants. So the most simple multi-tenancy approach on soft multi-tenancy is when you share not only the cluster, but also the Flux instance across tenants. So for example, you have a platform admin there with their own Git repository, and then Flux is observing all the changes on that repository and applying to the cluster on behalf of the admin. So probably this account would have like cluster admin rights, would be able to do anything across the cluster. And then in parallel to that, you have a different repository, which a specific team has access to. And every time that they apply any changes to that repository, Flux would apply those changes on behalf of the tenant. So for example, you can create a service account that is restricted to one or multiple namespaces, and then Flux would be restricted to that when applying those changes. And again, this is a control plane level restriction. So, all those isolation levels from host perspective need to be observed. Obviously, a platform admin can enforce that with policies and so on, but the core security primitives we're giving users is pretty much that control plane level. Conversely, you can have the hard tenancy or hard multi-tenancy, which you have dedicated clusters. So a way that this works quite nicely is you have a platform admin, and then you have a cluster for that platform admin, which is responsible, for example, for provisioning different clusters and bootstrapping them. So in this case, what you could have is on that platform Git repository, you have the state of the management cluster and also the initial state of these other bootstrapped tenants. And the great thing about this, for example, is, well, first you have the highest isolation level across tenants, definitely across tenants and the platform admin, but you can also bootstrap them in the same GitOps manner, completely automated, and have the whole thing work behind the scenes, version and so on. So this is as is. This is what we currently support in Flux right now. On top of that, there are some RFCs, so proposed changes that that we have pending that we definitely would like to get some views on, which are first about defining, those tenancy models in terms of naming and also what they entail. Again, like Flux is extremely flexible. So those two examples I gave, they're just extremes of the spectrum. You could have something in between, in which, for example, you have a soft tenancy in which you have Flux instances for each tenant, which can resolve some problems of like noise neighbors, or ensure that each tenant can have their intervals honored and so on. But you can also have other types of in between, in which you can force isolation levels with other components like kata containers or like gvisor and so on. Cool. So this is one of the RFCs. The other one is establishing a way to access sources across namespaces. So this is especially useful for soft multi-tenancies. At the moment, you have tenant A, tenant B. Their sources, the sources they create, because they have like secrets to access the given repositories and so on, they are restricted to each one of the tenants. With this RFC, we would allow sharing those sources across namespaces. There are some concerns, especially around having a different level of RBAC. So you have the RBAC from Kubernetes, which gives access to those objects themselves, but then you would also have a RBAC applied via Flux, which then would mean that you can reference to something that you might not have access via Kubernetes RBAC. And last but not least, we have Flux multi-tenancy mode, which pretty much define a lockdown mode. So for example, you can, so going back a few slides when I talked about the soft tenancy, and you can apply changes based on a given user or given a given tenant. This lockdown would do things like that, would enforce that every single tenant defaults to no privileges. It would also block cross namespace sharing and so on, and then users can go in and enable that on a need basis. So those are the key changes proposed at the minute, and now we'll hand over to Sanskar to talk about Flagger. Are you mute, Sanskar?
I'm sorry about that. Yeah, thanks, Paulo. So Flagger is a progressive delivery tool, which basically lets you automate how you release new versions of your deployments in your cluster. So if you think about it, just from like a principal point of view, you have Flux, which will basically pull from GitHub or GitLab your source and apply it against the cluster, right? And then your image automation controllers, they detect that a new version is available on Docker Hub of your image, and so Flux would reconcile against that, and then your new version is going to be up and running. But the thing is that if you're running some kind of a web service or something which is very critical, and you want to make sure that the new version does not have any bugs and all your SLOs and KPIs, like the key performance indicators, are being hit. So Flagger helps you achieve that. So the way it does it is that it basically creates a shadow deployment of the actual deployment that exists in the cluster. And what it does is it uses ingresses and ingresses and service meshes. So they have these traffic routing custom resources where you can define weights and certain headers depending on which you can specify which request should go where. And using those, you manage the traffic which is received by the primary deployment and the new version that you want to test. And you basically you measure the metrics using Prometheus or Datadog or whatever you measure how the new version is performing. And if the new version is performing well, and then you go ahead and promote it to be the actual deployment and you expose it to your users. So Flagger basically automates this entire process in a very useful manner. So that is progressive delivery in short. So Flagger by itself, by its very nature, because it does not react to external changes, it reacts to internal changes inside the cluster. Its target area is much less than Flux. It's not quite susceptible to those kind of issues that Flux is usually susceptible to, because it does not do stuff like remote apply or pull changes from external sources, right? But there are a couple of issues that we have identified previously. So one thing is the load tester. So a load tester is not part of Flagger itself. So it's a small application which is part of the Flagger GitHub repository. It's part of the code base, but it's packaged independently, and you have to explicitly install it. A vanilla installation of Flagger will not install the load tester as well. But we do use it heavily in docs for tutorial purposes and to get people up and running fast. So it's basically a small application which is an API. It's a web API which exposes a bash shell, and the deployment is has like the pod itself, which runs the load tester, will have tools like Perl and Hey and gRPC load testing tools and stuff like that. Even Helm if you want to run Helm tests. So these tools are installed for the convenience of users to get them something which they can use to test their new deployment quickly. So by its very nature, it proposes security risk because it's a load tester. So it poses security risk. And the second issue what we found was that Flagger allows some cross namespace referencing. So you can reference a glue upstream reference object, in some other namespace that you don't belong to. And there are the Flagger has this concept of metric templates, which basically let you define how you want to measure your SLOs, and those can also be cross namespace referenced, right? So that can be a bad thing when you're in a soft multi-tenancy setup where you're sharing the cluster with tenants isolated in namespaces. So we have done things to address these issues. We just wanted to know if it's enough, or we need to do something more. So regarding the load tester, what we did was we made sure that all requests coming to the load tester can have a namespace, can have their namespaces validated. So how that works is that you can specify which namespaces the load tester should accept the request from. So when Flagger uses the load tester, when Flagger uses the load tester, it sends a payload. That payload, the JSON body, contains the namespace of the canary object as well. So that way, so what you can do is people can specify that the load tester should only accept requests originating from a canary in this namespace. So that is a kind of a mitigating thing that people can use in order to escalate down the security threat. But if people just want to be safe, they shouldn't just install it. Like if you want to be safe and if you don't want to take any risks, just don't install a load tester in your cluster. Have some external tool which does it for you outside the cluster. And to address the cross namespace referencing issue, we added a flag recently to Flagger where cluster admins can define whether or not tenants can share their custom resources across namespaces. So you can just set that to be true. So set that to be false. You can set the allow cross namespace to be false, and then you have basically locked down each tenant in their namespace, and you don't allow them to access custom resources from other tenants. Yeah, that's pretty much from Flagger.
Brilliant, thank you. Yeah, I think these are the links that you shared afterwards. I'll share this link to everybody, so folks can see the links on these slides. Brilliant. Yeah, and one of the last points that I wanted to cover is pretty much the security review scope, as I mentioned before. So that is around the multi-tenancy, what we have right now, and the concerns we have right now. And I wanted to just point out, so on the issues we created, we already linked the self-assessment. I'll share that afterwards as well. We recently created a security best practice for Flux, in which we highlight key features and key specific settings, especially when talking about multi-tenancy, how to do that securely. So, one of the points is the existing implementation based on the security best practices, and then the proposed changes, which are, the pending RFCs and as well Flagger, all that into a multi-tenancy setup. And I think that is pretty much the end of it. Does anyone have any questions about, Flux, Flagger, our multi-tenancy, or anything that we said is not clear?
Thank you very much for the presentation. Yeah, I'm interested in terms of secrets management for Flux. When looking at where those credentials, especially maybe for a centralized cluster that's remotely deploying to others, what mechanisms does Flux support for storing those credentials? Are they just plain Kubernetes secrets? Is there anything specific?
That's a really good question. We recently created a page on that. I'll actually open here as well, so everyone has that page. But basically, we cover, pretty much everything, right? So we just need the secrets to be on the control plane. So all the Kubernetes native secrets we support. We also support things. Oh yeah, let me just go up. We also support things like sealed secrets and so on. We don't support direct access to things like, for example, votes. But for that, you could do something in between, like have like an external operator, which then loads them into the cluster. One additional thing that is Flux specific, which is this point just here, is the ability of Flux to decrypt secrets on demand using Mozilla SOAPs. And there we kind of highlight a few points why that is good. Obviously, it's not everyone that has the security requirements or appetite to have, for example, those secrets encrypted into a source. But again, like we support a different approach for that nonetheless. Does that make sense?
Yes, thank you. And in terms of how those secrets are used, are they, and I guess maybe this is more a sort of code review than a usage, but are they loaded on demand, or are they all loaded at instantiation of the process and then kept in memory?
Well, that is another really good question, right? So from a Flux perspective, we load them on demand. However, the controller runtime has a caching mechanism that actually lists all those secrets across the cluster by default, I believe, at reconciler registration level. So, from Flux perspective, we do on demand and so on. But I believe the underlying libraries that controller runtime has would load all of them behind the scenes. And to that point as well, like we recently actually had some contributors asking how we can lock that down, because, for example, given the caching mechanism on controller runtime, that means that you need to have least secrets across the cluster, across all the namespaces, even if you have a Flux instance that is, that might not need that. We found a few workarounds for that, but again, like this is mostly an upstream problem rather than Flux problem.
And I suppose just to flog the horse while it's there, is it then conceptually possible for well, maybe the question first of all is, are there considerations for a malicious internal actor in Flux's deployment model? So would it be possible for me to deploy another or my own service with Flux's service account keys, for example?
Well, it really depends on. So if we go back to this, right? So especially when you're talking about soft multi-tenancy, which is you have multiple tenants on the same cluster. If it's configured based on the best practice, no. So basically, when a tenant tries to apply something into a cluster, they will be restricted from a control plane level to the service account that was assigned to that given tenant. If this is not properly configured, then yes, you would be a cluster admin, which would mean you can pretty much deploy anything across the cluster. But one thing to highlight as well is that this does not protect users against the inherent Kubernetes problems of sharing a cluster, right? So, for example, if you're deploying something on the same host as, another tenant, if you don't have any sort of host isolation, you would be able to get access to, secrets and so on.
So while you're on that page, is there anything in Flux that would allow you to deploy the Flux server itself without having cluster admin? And so if you were a user that was already isolated to your one namespace, could you deploy your own instance of Flux, not rely on Flux to provide all the isolation, but just the inherent limitation of the user deploying the Flux instance?
Yes, we do support a namespace-specific Flux watch approach that would be restricted to the service account of that tenant. And this is actually one of the approaches that is recommended, especially when you think about honoring intervals, right? So Flux ultimately is a controller, and controllers, they observe changes on the CRDs, right? So for example, if you have a tenant that has way too many objects being monitored, they might actually take, they might affect other tenants' ability to have those intervals honored. But that is just the nature of how Kubernetes work, especially if you have one instance shared across multiple tenants. But yes, the answer is you will be able to isolate that per tenant.
So you would end up, in this picture, you would end up having an install of Flux in each one of those namespaces?
You could, yes.
Okay.
Any more questions? Anything? So on the issue that we created, we started a self-assessment. We also started, considering the attack surface and quite a few things. We started also a draft of a threat model. There's a lot of things that again are inherent of sharing Kubernetes clusters and sharing applications across tenants. But yeah, I definitely think it would be good if folks could have a look and feedback on that. That would be really nice.
Great, thank you very much. I know Rowan's having some trouble with his microphone there. So just proxying a couple of questions. Is there a way of ensuring on Cluster Bootstrap that platform policies are installed before application repos? So enforcing an order to different layers or different levels of control.
Yeah, that's a really good question. And I think there's two ways for that. So for example, Flux customizations have the concept of depends on. So you have the initial one, which is pretty much bootstrapping Flux. And then what you can do is the next ones you create, you just make sure that they depend on the layer above or below, depending on how you think about it. So that's one way of doing that. And that should work fine. So, which means if you have a new change at a platform level, let's say, which is not working, that will wait, like all the other ones that depend on that will wait that to be successful to then kind of carry on, a potential change that would break everything else. Another way of doing that as well is when we talk about hard multi-tenancy, is that you can actually create the initial bootstrapping of a tenant cluster. So you actually installing Flux, all the best practices, you may be limiting the powers of that Flux instance as well. And then after that, Flux will kick off to then bootstrap the user based on their repository. So again, given that Flux is really, really flexible, there's definitely loads of ways of doing this properly. What we're trying to make sure is, especially around our documentation, is to highlight what we believe are the best practices, so folks can actually, consider them first before trying to build their own.
Just a follow-up question was, can that be cross namespace? But I assume because it's cross cluster, then yeah, of course, because of that dependency. And the other question from the good Dr. Baker is authentication for cross-cluster Flux. Can this use cloud-based workload identity, or is it always a service account token?
So at the moment, the remote apply is based on a kube config. By default, we disable the exec possibility. So for example, in some cloud providers, you might actually have I think AWS on EKS has a executable that would get a JWT token on demand, and then, pretty much kubectl will pick that up behind the scenes. So all that is basically supported. You can enable that on demand, but as long as you have a kube config that is valid, we will enable, applying things on a remote cluster.
And just because I'm not sure that I picked that up correctly, when you say exec is not supported, do you mean it's not possible to execute a binary for that token exchange by default?
Yes, you need to add a flag to that. And the reason for that is, well, it was a CVE that we found earlier this year. So especially if you're in the same cluster, so imagine you're here, what a tenant could do is actually leverage that to pick up the cluster admin token and then be able to execute things on the cluster as an admin. So because of that, we disable that by default, but you have a flag that you can enable and then carry on using as you see fit. Yeah, but it's especially around that, again, given the kube configs enable you to execute anything, our recommendation on that is to kind of use that coupled with other things. So for example, have some sort of app armor or SE Linux policy just to ensure that can only execute the things you actually want them to be executed. Otherwise, any tenant that can create a customization would be able to, pretty much execute anything at the controller pod.
Awesome. Well, we've still got a couple of minutes left. So I guess another question could be, where are you most worried about perhaps an escalation, or where, if people only had a short amount of time, where would their eyes be most useful to you guys?
I definitely think around, the RFCs, especially on the sharing across the cluster or sharing across the namespaces, right? So that is something that it would be great to have some eyes on. On soft multi-tenancy, I think would be the core concerns as well. But again, there's so many things that are inherent of Kubernetes or sharing the same network that it's some things is a bit silly even for us to kind of mention on our best practice, but we actually put that anyway, just to highlight. But what I'd say is pretty much the RFCs, if you guys could have some eyes on that. And then on soft multitenancy, anything that you think that might be Flux specific, rather than, you know, or even recommendations. How shall we recommend users to, you know, secure this? Because there are some guarantees we cannot give because it's based on how the Kubernetes is set up. So yeah, anything on your side, Sanskar?
No, pretty much all good. Yeah.
Right, really appreciate the presentation, gentlemen. That was very clear, and we've got some excellent notes here in the documents. So with that, it is a big thank you to the Weaveworks and Flux maintainers for the presentation. We will be back in 2 weeks' time, and next week's session will be on US time on the Tussaud, which I will admit to still not being sure I'm pronouncing correctly. It is this issue here. I don't know if Brandon can correct me. Is that how I should be pronouncing it?
You're asking the wrong person.
So this is a KMS provider plugin, and we will go through a walkthrough of that on US time. The issue that we've been talking about today, if as you mentioned, Paolo, it'd be possible to drop the slides onto that issue just to notify people who weren't able to make it today as well. And of course, this is on YouTube, so we will link that through there too.
I just want to add one thing. I think Sanskar and Paolo, you may want to ping around. Now I know we have an existing item with the TOC to kind of provide comments and kind of just a thumbs up on the multi-tenancy review. Arana has been looking at that. So if you want to ping her and have a discussion, I think that would be helpful. You can help move that forward.
Brilliant. Thank you very much for that. We'll do that right away.
Yeah. Thank you.
Super cool. All right. Have a wonderful Wednesday, everybody, and see you next week.
Thank you, everyone.
Thank you.